Alright, finally here in example 5 we get to graph one of these equations. So previous examples we've been looking at writing equations, and we've been writing equations of graphs and given some different values and things like that, and now we'll take an equation and actually put it here on the coordinate plane. I'm going to have to do some of this work on the right hand side. It might get a little cramped over there, so I'm going to try to move this over for you so you can see. We already have our negative pi to 3 pi here, and so we don't have to worry really about that or the labels here. What we do need to figure out though is the amplitude, and that's 3, and I'm going to put a little star, no shift, no reflection, excuse me, no reflection, because it's positive. We can go right down the line if you want, or you can do the vertical shift down 2. It doesn't really matter. As a matter of fact, we'll probably put those together just because we're going to do those first. So the vert shift is down 2. For the period, that's going to be 2 pi over k. K is 2, so that's pi. And then now we need to do the phase shift. Well, this is the last thing we'll do actually on the graph, so it's nice to do it last here too. And we'll do, let's see, c, which is pi over 2. If you want to put the negative sign there, you can. It doesn't really matter. And over 2. This is kind of a tough one for most folks. So let me have you write this 2 as 2 over 1. And remember then to just multiply by the reciprocal. Oops. That is not the reciprocal. 1 over 2 is the reciprocal. So we'll put 1 over 2 there. That's gone, that's gone, that's gone. Well, it's really 1, but anything divided by 1 is that same thing. So it looks like it disappears, but the value is still there. And now we'll have the phase shift being, looks like pi over 4. The direction, I just always go back to the original equation and say, oop, it's a minus sign, so I'm going right. So pi over 4 right would be the direction. When I graph these, what I do is I draw a helper graph without the phase shift, and then I draw the phase shift. So we're going to do the amplitude, the vertical shift, and that should be DOWN. It's not Dow and Wagner or something like that. Heating and air conditioning here, this is down, so there's a plug for you guys. And the period is pi, so what we can do is we can actually draw ourselves kind of a little, a graph that has all this and takes all this into account. So let's do that. Let's start with the vertical shift down 2. And so this right here is going to be, and you can do this lightly if you wanted to, it's not part of the graph, but it's a helper line. So that's my midline. My amplitude is 3, so I need, this is, looks like that's -1 here, 0, 1 would be here, so I need to go up 1, 2, 3. So if you go up, let's see here, I'm getting this paper all discombobulated, give me a second here to make this a little bit nicer for you. Oh, there we go, that's a little bit better. Hope you can see that stuff on the right hand side. So anyways, we need to go up 1, 2, 3. That's our amplitude. There's no reflection. We'll deal with that here in just a second. So this is our top line. This just kind of helps you keep the graph in bounds, you know. This would be -3 and -5. So we need to go 1, 2, 3 down. That's our amplitude. Remember, the amplitude is the distance from the midline to either the bottom or the top line. So this is our bottom line. And now I like to take our period, which is pi, and divide that into quarters. So what I'm going to do is I'm going to draw a line here. I'm going to draw a line here. I'm going to draw a line here, right here, and then here. You'll note that there are 5 lines, but that splits the period into 4 different pieces. And you know what I should have done is I should have drawn these down to the bottom line too. So you just draw it straight all the way to the bottom. What we're going to do now then is we are going to, we're going to draw our graph without the phase shift. So right now we've got a sine curve. The sine curve would start at the midline, go up, there's no reflection, and at the first quarter it's going to hit the top line. Then halfway through the period it's going to come back down and hit the bottom line, or hit the midline, then come down at the third quarter, and then come back up. So if you drew a helper graph, here is what your helper graph would look like. And we really just are looking for these points. This is just one period, so you'll notice that everything here in this green or sea color, gosh, I don't even know. Maybe you can help me out, send me an email or comment on the video and say, you are colorblind, I'm actually not, and don't know what you're doing. So to me this is like a greenish blue, I don't know. Anyway, what we'll do here is then we'll draw the actual graph in a much different color so you can see what the actual thing is. So the graph itself is going to be, I'm going to try this in red. We'll see how we do. Okay, so we need to go pi over 4 to the right. So this is pi over 2, and this would be pi over 4. So each individual grid line appears to be pi over 4. Check it out, pi is split up into 4 pieces, so each piece has got to be pi over 4. And we're going to go to the right by pi over 4. So every point is going to be moved to the right. This one's going to be here, this one's going to be here, this one's going to be here, and this one's going to move over. Okay? Now, we can draw one full period of this thing, make it nice and curved. It's kind of hard when it's up and down like this a lot. But do the best job that you can. Just take your time. It's not going to be perfect, but it could be good. Close. It's a little wobbly there. And we need to go all the way to 3 pi and negative pi with this. So the cool thing about a graph like this is the period just repeats. So we know that we're going to have the graph come up to the top, then come down to the bottom, then it's going to come up to the top, back down here, and then all the way down. And that's where we need to stop. So we can do this side of the graph. Boy, if this isn't fun, I don't know what is. More fun than a barrel of monkeys, I'll tell you that. And by the way, you can check your work by picking any point that's on your graph in red or on your final graph. And we've got 2 equal signs here, so we'll keep that, by the way. So you could take any one, and I'd recommend maybe picking, you can pick a midline one if you want, but if your graph is flipped from where it should be, then actually one of these peaks or one of these valleys here at the top or the bottom line will help us out the most. So let's continue this graph to the left, and I think this is going to come down here, and then come up here, and that period's that's good right there, and then going to come back down, and then wind up here. And so what we'll do is we'll draw this all the way up to the top, all the way down. Nice curve. Just take your time. You can fast forward through this if you want at home. Didn't take my time on that one. And there it is, the graph of this equation. Looks a little bit weird, but that's what it is. It's a sine curve. It looks like it's compressed a little bit. It's got a different period going on, a little bit of a phase shift, and voila.